So, hello everybody. For those of you who don't know me, I'm Steve Holden. And this is all down to me, in fact, because I started PyCon back in the States 20 years ago now, in 2003. And I'm happy to say that that conference is still going strong. And so I've also been involved in community development in various ways as the director of the Python Software Foundation and part of the time as its chair as well. What makes a good community conference? Well, if you've got crap speakers, you're going nowhere, no matter how good everything else is. So good speakers and interesting talks go without saying. The really great thing about a community conference is the chance to meet people and to learn new things. And if the organization is helpful, so that there's coffee when you need coffee, food when you need food, the presentations run to time, then that really does help as well, and it makes things go much more smoothly. Reasonable pricing is important because we're all aware of the cost of living. But the most important thing, and the thing without which you cannot have a community conference, is a community. And we started we didn't start the Python community with PyCon. There was already a fairly active online community, and there were some conferences. But yeah, basically, there wasn't much going on in terms of organizing those conferences. The preceding conferences had been organized by a commercial organization. So I said to Guido, I was lucky enough to live near Guido, and I said to him, really, the community could do a better job. So what is a community? Well, a community is a group with common interests. Python and conferences are obviously interests of people who have attended this week. The aspect of common ownership is also important as well, and we've all got a kind of ownership stake in Python because it's an open source. Hands up, anybody here actually contributed to the Python code at all? Good for you. Yeah, more people should. Everyone seems to think it's horribly difficult, but in actual fact, almost all contributions are welcome. And PyCon Ireland itself is run by a non-profit, so that's kind of community property as well. But organizing a conference takes energy and effort, and it's not just something that happens 2 weeks before the conference. There's a consistent effort that's needed pretty much across the whole planning year. You may not realize, but the planning for next year's conference has probably, I've not spoken to Nicholas about it, but I imagine the planning is already starting. So it's fun, and it's more fun when you can get the community involved. And if I can make the video work, which I'm never entirely sure I'm going to be able to do, then this is a video of the bag stuffing at PyCon India. And the way it works is that each piece of swag is laid out on a row of tables. The people inside the table pick a piece up and put it in each bag that passes. And then there's a chain of people who take a bag and they go around the outside of the tables. And when they end, then a bag has been stuffed. And as you can see, people are really miserable there. So the other thing is that the results that you get from a conference depend on the effort that the organizers put in. And it seems very obvious that therefore the more organizers you have, the better the results are likely to be. Not only that, it means the effort's shared. So each organizer has less to do because the effort is shared over a greater number of people. None of this is rocket science, right? All makes perfect sense. So the trouble is the community tend to treat conferences as though they do just happen. And so everyone leaves it to the organizers. And of course, the organizers are then left wondering what the hell they're supposed to do with all these expectations that the community has clearly developed without any clear feedback and very little input. So, are we a community, or are we just a bunch of consumers, is my question to you. Are you just here to take, or would you like to give a little back as well? So my suggestion is, if you want to PyCon next year, it's time to get involved. You don't need to do a lot. you can do, you'd be surprised how little time you actually need to spend on particular tasks. But Nicholas, I'm sure, will be able to reel off a list of things that he has to do every year. And I'm suggesting you try and save the current organizers from the fatigue that comes with being faced with the same tasks year after year, the same old faces and no new help arriving. Thank you is very nice when you're a conference organizer. It's very nice indeed, but it isn't enough. It's always much better to hear, what can I do to help somebody who actually wants to help the conference move forward? So you may think, well, I don't know a thing about organizing conferences. Guess what? When I started PyCon, I didn't either. But I managed it because I had lots of help from the community. When the first PyCon opened its doors, I'd set up a registration desk with 4 people, with 4 places, and the first 4 people who came through the door were told, you're manning the registration desk. And it worked. People actually loved to be given the responsibility. They loved to be doing something for the conference. Some of those people still go to PyCon 20 years later. So, hopefully, I'll see you next year. We shall see. Thanks, everyone.
Okay, so let's talk about garbage collection. So, all of Python developers should know that there are 2 ways how garbage is collected in Python. So there's the reference counting, and I think it works for like 95% of the cases, and the release is 95% of objects. And then there's generational stop the world garbage collector that kicks in when we, by accident, created some cycles and the objects just don't go away because the reference counter gets decremented. And the important thing here is that it's stop the world. So it means not only it takes some CPU time, it also prevents your code from running. And yeah, and here I have to say that there are actually 2 types of objects inside the C Python. There are like primitive objects which only have the reference, and then there are garbage collectible objects which are typically like lists, tuples, dictionaries, classes, and so on, which have this special header for garbage collection. And so I want to see how this garbage collection works. So if there's a package inside the Python called GC, and you can look at what are the default settings in GC. So for generation 0, this setting is 700. So it means that once 700 GC collectible objects will be allocated and not released, this garbage collection will kick in and try to release some of those objects. And we can easily test that by adding some GC debugging. And let's say here we allocate 800 strings. So when nothing happens with GC, because the strings are those primitive types which only rely on reference counting, not on GC. But if we do the same and allocate 800 dictionaries, the garbage collection kicks in. It does some work, but actually it doesn't do anything because these dictionaries are loaded in the X, and those objects get checked, and then they go to the next generation. And imagine your code using, like loading some CSV file, and every 700 rows it will kick in the garbage collection and do some work for no good reason. But now let's talk about Django query set. And the query set is interesting because for some reason it made the decision that by default it will cache all the objects that it retrieved. And if you want to avoid the cache, you have to explicitly say that please do this .iterator. And so how bad is the garbage collection with the Django query sets? So I have this simple model. It has only like primary key, balance, and version field. So there are 3 fields, not much. And if I have this loop which on the surface does nothing bad, I want just to iterate through the object because those objects get cached. It actually just with 200 objects, it already kicks in, triggers this garbage collection, which tries to do something, but in reality it just wastes CPU cycles. And if we want to avoid this, we have to disable the caching. So by doing that, so we got rid of garbage collection, and this works much faster. And then the models are not so simple. So here I added one related model, and I want to load it with this select related. And here it's sufficient to process just 100 records, and the garbage collection kicks in. Because in total, it turns out that those 700 objects, which are GC threshold for generation 0, is roughly equal to around 200 Django ORM objects. So in every time you load 200 Django ORM objects, you trigger garbage collection. So what to do with it? You can use .iterator if it's possible. You can also increase those thresholds because those are like really, really small. The downside of it is that if you get a real memory leak, you will know about it maybe too late. The thing I like the most is this, there's this disable GC package which has the context manager and annotation for function, where you can explicitly say that, oh, this function will be loading some data, please don't do any GC during that. And there's also an article from Instagram, and they are running their Django in production with this garbage collection disabled. So they are setting this threshold to 0, which just disables the garbage collection. So that's all. Thanks.
I haven't been to any talks or anything because I got here a bit late, and then I had an idea in the back of my mind, and I thought, why go to any talks, listen to anybody? I could just mash keyboard until something works. The idea came about because I think Anaconda and Microsoft made a big splash a few months ago about how you can run Python in Excel, and I saw their implementation, and I was like, poo, 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 that's so bad. I don't want to run shit in the Azure cloud. But it was like, they should have done better, and they could have done better, and this is a me calling them out a little bit. So if you don't know what PyIodide is, it is a fantastic little effort that sort of blew my mind when I first saw it. It's Python and a whole bunch of really interesting libraries compiled down to WASM. And I know ECMAScript sort of started out to see if you could run Quake in it, and you could, and that was all cool and stuff, but I can't believe this is actually being useful now. So I was vaguely aware of PyIodide, but what really sold it for me was when I saw the Jupyter Lite project with the entirety of Jupyter Lab compiled down to WASM. This is running inside the browser. There's no server backend, just loads the assets, and everything is happening here, and you can do all kinds of cool, neat things. So I started that after lunch today. It's like, okay, how far can I get? Well, look. Sure, cool, yeah, it runs on my browser. Thanks. But the point was, hey, I didn't like what Microsoft did. So I didn't actually get it all done. I did run out of time. You can create Excel add-ins using something called Office.js. So when Microsoft started moving everything to the web, they went like, well, we have to have something other than VBA. And they decided to make JavaScript a first-class sort of citizen, and created all the bindings for it, which is great. Thank you, because I don't want to write VBA. I really don't want to write JavaScript, but I'd rather write JavaScript than VBA. But ideally, I'd just write Python. So when Microsoft Anaconda came out, and I had a nagging feeling in the back of my head, there's a better way. And this is sort of the add-in test. So this is the same instance of PyIodide compiled interpreter running inside the Office context. I was trying to create a full, do the exact same thing as a Python UDF. You can see how that didn't work. And with a little bit more effort, I think this is totally doable. It's just that I'm a terrible, I don't know anything about Node. And I'm a terrible JavaScript programmer, and that's the only reason this hasn't worked. But some more effort, and I think we can just do a better job where your data doesn't have to go to the cloud to be processed in Python. And we cannot write VBA, and we cannot write JavaScript, and we can just do more Python. Thank you.
What I want to show you is one of the reasons why I really enjoy Python, and that's the ease with which I can create things that essentially just look cool. And cool is the word that really matters. So I'm going to be using Pygame. And I know Pygame is not supposed to be used like as a graphics engine, but it's just simple. And what we want to do is cool things that are simple. So I'm going to create a simple screen, which is going to be 400 by 400. And just shout if something surprises you or if something looks weird. And now what I'm going to create is an infinite loop to handle Pygame events just so that the window doesn't freeze, right? Now this is irrelevant, this is the infrastructure. Now what I'll do is I'll define a very innocent looking function. It's just z squared plus c. Very innocent, right? Now what I'll do is I'll go through the screen. So I'll go through the rows and columns of the screen. And I'll create a complex number depending on where we're at right now. So the real part of the complex number is going to be, and now you don't have to, this is going to look magical, but just because I was testing numbers, right? So what I'm going to do is take the 400 by 400 and change the coordinates so that it's a 3 by 3 square that's slightly off-centered. So I'm going to take the x divided by width, that takes it to 0, 1, multiply by 3, you have the 3 width, and now I'm going to change the center, and now the imaginary part is going to be similar, right? This one can be centered, it's going to be fine. And now I'm going to create z. It's a complex number with these real and imaginary parts. Now I also need a c, because if you see here, f takes 2 numbers, and I'm going to need both of them. And now what I'll do now is, sorry for the repetition, so what I'll do now is create just a constant, magical constant, because they look great. And now what I'll do, again, sorry. So because I have a very serious limitation, I cannot do two things at once. So when I'm typing, I can't think. And if I can't think, I can't speak. And if I can't speak, I say the same thing over and over again. So now what I'll do is, for each pixel, I'm going to call the function f a bunch of times. But not a random number of times, only while the current iteration hasn't been for too long and the absolute value of z is smaller than 2. And if these conditions are satisfied, what I'll do is I'll update z. Very innocent looking, yeah? And now what I'm done, one of two things happen. Either the absolute value of z is greater than 2, or it isn't. And so I'm going to color I'm going to color the pixel I'm in, depending on whether I have a number with a big absolute value or not. Now, British spelling here doesn't work for Pygame. I'm very posh. Thank you. And now let's make this a... I never know which color is which, so I'll refrain from saying... Sorry? Black and white. No, I know it's black and white. I don't know which one is which. So, oh, again, I always do... So I did a couple of trial runs and I always forgot to update my screen. Right, so if I was drawing on the surface, this is just the way Pygame works, we need to flip the screen. And now this creates a very interesting figure, and it didn't take a lot of code. And I'll take 1 more minute to make this look prettier. And now the fun part is you can spend a lot of time just tinkering with the colors, which is what we're going to add here. We're going to add colors. So instead of black and white, I'm going to create a color for each different value that the auxiliary variable iter can take. So what I'll do is I'll create an empty, quote unquote, because it's not really empty. I'll just create a random color, doesn't matter what values I put in, and now I'm going to assign the HSLA color to it. And this is where you can get creative. Again, this is just a value that I played with and it seemed to work fine. It's not something you just... I was not sitting there and I realized, yeah, of course I need to do the power of 0.8 because that's obviously the perfect choice. So that's not how I did it. I just spent way too much time playing around. So now we append the C, and for the visual effects, we get rid of those, and we take the colors and we index with the variable iter. Now, this is slightly bigger now, so it's going to take a blink of an eye, except, yes, it works. Okay, so this is why I really like Python. It didn't take me a lot of time. Of course, I rehearsed, but it didn't take a lot of time, and it looks neat, right? So if you want the code and just a little bit more background, you can scan the QR code. Otherwise, thank you for your time.
So hello everyone. Wow, it's good to be here. We are the community sponsor people. The two of us, Jimena over there, Vicky over there as well. And we're here to talk a little bit. We have a booth at the entrance. I hope you saw us when you got in. And we're here to talk a little bit more about the things that... Oh, yeah, you clicked. Okay. About the booth. So that's us. Jimena is not there, but she's there. Say hello to everyone. Yes. Very good. And this is Mia. And Mia is now going to take it away. Go.
Hello everyone, so my name is Mia and I would like to talk a bit about EuroPython Society. So how many of you have ever heard of EuroPython Society? Raise your hand. Okay, so around half of people. And how many of you do know what it is? 1, 2, okay, around 10 people. So we are a non-profit organization that supports Python communities in Europe. We promote the use of Python and we help local European communities with grants. So what does it mean for you is that if you're a conference organizer or meetup organizer or any kind of event, and if you need any help from us, please scan this QR code and you can read more about the grants that we are giving. Also, another thing that we do is that we run the EuroPython conference. How many of you have ever been to EuroPython conference? Okay, around half of people. So EuroPython conference is the oldest volunteer-led programming conference on the planet. So here are just some numbers for you to have some sort of idea how it looks like. So there's usually around 1,500 of participants. So it's a big conference, the biggest European one. We also have lots of videos online. So feel free to check our YouTube channel. We have around 10,000 of views. So we have lots of different videos and lots of different interesting topics. In case you would like to visit us, but you have some financial struggles, we also have financial aid for applicants. And as you can see, we have lots of speakers, lots of sessions. There are also lots of different events for you to have fun at, lots of tutorials, etc. So, next edition, if you want to find out where it is, please scan the first code. This is our newsletter, so as soon as we announce it, you will find it out. And in case you've ever been to EuroPython and you really liked it and you want to help us and you want to get involved, then please scan the second QR code and join us as a volunteer. And now we would like to talk a bit more about PyLadies. So, ladies.
Thank you, Mia. Okay, so cool. PyLadies. So the question we get the most is PyLady only is for ladies? And the answer is no. PyLadies is for everyone. Allies are more than welcome. And PyLadies is basically it's community, and it's a network of chapters around the world. It's a huge community. There is then the PyLadies Dublin chapter, and we have Vicky here, the founder of PyLadies Dublin. And PyLadies Dublin was founded in 2013 in this building, right? Like I think upstairs in this building. So this year is the 10th year of PyLadies, Dublin. This is a picture of the actual 10th anniversary meetup event. I was there, although I'm not in the picture, and it was a very, very nice one. And yes, so it's a very large community. And this year is the first time that we had a worldwide conference, which is for all the PyLadies chapters. And it's a worldwide online conference that is going to happen from the 1st to the 3rd of December. It's multi-language, multi-time zone, 24 hours everywhere. If you're interested on it, there's a nice QR code over there. I'm very excited about it. I think it's going to be amazing. And it's also the first time. And yeah, cool. So that's it. Thank you very much. If you want to know more, just come and say hello to us at the booth. And this is it. Thank you.
Hello everyone, I'm Rodrigo, and I'm here to show you one of the things I like about Python, right? So what I'll show you is a program that builds this simple calculator. So it's a tkinter, I don't know how you say it, sorry. Okay, so tkinter is fine. So it's a tkinter is fine calculator. You just press the numbers, and it evaluates what's written there. It's very simple, and I found, this is the source code for what I showed you, I found it online. And what I'll show you is how to take this piece of code and make it more elegant. Yeah? So the first thing you can do is you can remove some lines that you don't need. For example, the return BT, which is the 5th, 6th line over there, it's not needed. And you can, at the bottom, you can use an enumerate to get rid of the keys. And it also cleared up a couple of things inside the list comprehension. Now what you can do next is realize that statements are bad and expressions are good. And so what I want to do now is, and this only works in Python 3.8 or after, I'm going to replace all the assignment statements with assignment expressions, because I can, right? And so that's what I did, except we have a problem because there's 4 assignments that I could not get rid of because they're using indexing, which are this text inside DTPress, BT, which stands for button, obviously. So inside BTPress, I could not get rid of the assignments. So what I'll do is I'll create an auxiliary function that updates the display text. So we create a function. Now I said that statements are bad, that's why we have a lambda there, because it's an expression, right? Now what I can do is, I can use the function I just created, otherwise I could just remove it. So we use the update function. Now what I like about this, and of course I'm being a little bit extreme here, but the general idea holds, is that you should, for some measure of should, try to not nest too much code. And if you look at what I've done there inside the if, elif, else, I've called update on all 4 branches. The only thing that's really changing is what's inside the update. So what I can do is I can extract the logic so that it's clear that what I'm changing is the argument, because the function call is always the same. But now, if I'm using an if, elif, else to assign a value to a variable, I might as well just rewrite the assignment with not 1, but 3 conditional expressions. And this is what I was talking about across multiple lines, but you gotta save lines. So we're going to flatten it out, and because now we will have a flat expression, we can change BTPress for a lambda. And now I wanted to keep the font size kind of readable, so that the code just keeps on the right, yeah? So it's hidden because it doesn't really matter. So what, it doesn't. So, oh yeah, now I want to zoom in a little bit, yeah? Just if we are ignoring whatever's on the right margin, we can zoom in just a little bit. No, it's just so it's easier to read. I feel I'm being mocked. Now, there's 2 statements left. It's the import statement and the def over there. So let's get rid of the import statement. Apparently there's a built-in function that does it. I'm not saying you should, I'm just saying you can, right? And now, and honestly, I think this is the nicest, the most entertaining part. Entertaining as in, because this has pedagogical value. You shouldn't do this because you might get fired. But there's some, or your PRs will be probably rejected. But we are doing interesting things. And now the final challenge is realizing that BT draw is going to stay a statement unless we figure out a way to combine the two expressions that I have over there. Now, can I see your hands up if you know what Boolean short-circuiting is? Short-circuiting. Wait, no one knows? So very few hands. No shenanigans. Boolean short-circuiting. Like if you have A and B, if A is false, we don't even get to B. Okay, so if you know short-circuiting, you know what I'm about to do. I call it long-circuiting. So the first expression evaluates to true, or to truthy, because a button, a class, is truthy. And so I can use let me think for a second. I can use an AND to put the two expressions together. So I moved the bt.grid, I moved it to the right of the assignment to button, and I added an AND in there. It's almost at the right of it's at the right end of the margin, right? So now there's a single expression inside the function. I can make it a lambda. And now all I have in front of me, actually on my side, in front of you, it's a bunch of expressions. And you already know how to put them together into one expression. What do you use? It's the something circuiting. What is it? It's the long circuiting. Yes. And so now I added it's just so you see which ones you use. And now what's interesting is going through the lines and figuring out where to use an AND and where to use for some measure of interesting. It's interesting to figure out which one goes where. And then since it's all one expression, you could just fit it into one line, which is a very elegant line of code. And now, I mean, maybe I sound convincing, but I want to show you that it actually runs for some measure of runs, because I couldn't get it to run on my own computer because I couldn't install Tkinter is fine. So what I'll do is I'll divide by 6 here, and it appears to be working. I don't know. Should I calculate something else, or are you convinced that it works? Yeah, okay, so once again, thank you for putting up with me, and if for some reason you want the code, yeah.
Good evening, everyone. So today we're going to talk about currying. So do we have any kind of Haskell programmers, OCaml, JavaScript, any functional language programmers here? Got a few. So Haskell is a language which is designed to be pure functions. So you can write purely functional code without any side effects. So here I have a small example. I'm holding my friend's laptop hostage, so I don't have the compiler installed on this. But what this does is it adds two numbers together, x and y, and it returns x plus y. Now, let's look at the type signature. So we see we're defining something called add. It's an integer, so it's a function which takes an integer, returns a function which takes an integer, hinted by the arrows, and then that returns an integer. So that means that we're not actually passing the two arguments in at the same time. What we're doing is called currying, named after Haskell Curry, who was inventor of the Y Combinator. That was like the big thing about him. So this is from the Haskell wiki. Currying is the process of transforming a function that takes multiple arguments in a tuple as its argument into a function that takes just a single argument and returns another function which accepts further arguments. That's a lot of words. So here we have our boring addition function in Python. We see it's just going to return a plus b. We can run it and prove it. And we see our generic add example is going to return to number 3. Now, we have this function called genAdder. And this takes one argument and is going to return to us an adder function. So we have genAdder A, and we have this hidden add function here, which is nested within it, and that takes an argument b, and that's going to return a plus b. But we're going to return the hidden add function. So what we can see here in our generate adder example is we're going to generate the adder with the first argument being 1. Then we're going to call that with the second argument, which is 3, and this is going to return the number 4. So let's create a function which will increment a number. We can do this by running genAdder with the number 1. So what this will do, as you'd expect, is the next argument that it takes, it's going to increment it. And we can even do one that adds 20. So we can see here in our increment example, inc10 is going to return 11, and add 20 with 33 is going to return 53. Now let's generate a multiplier. So we can do the same thing with our adder, where we can, pass in the first argument, which is going to be our value that we're going to use to generate the function. And then we're going to have our hidden multiplier function, which is going to return the actual product. And we can see we can generate a diameter function from this. So this diameter function takes in 2 pi, and then we can use the next argument as the radius of our circle. And we can see here, this will spit out the number 62.8 with the floating point error. And we can even use this to model, gravity and our falling speeds. So we can see here, we're going to pass in the number 9.8, which is the gravitational acceleration of the Earth, roughly. And then we'll ask to generate the fall speed after 10 seconds, and that's going to be 98 meters per second. Now we can start really pushing ourselves. We can generate an adder and a multiplier at the same time. So we're doing the same thing where we're nesting a function within a function, and then within that function we're nesting it again. So let's go back to Haskell very quickly, just so we can kind of look at this through the way it's actually designed. We can do add, or this is going to be similar enough to what we have in Python. So we can see we're doing the same thing where we're generating a function, which returns a function, which returns a function, which returns an integer. And we're going to be doing the same thing here, where we're defining our adder multiplier, we're defining our secret adder, and then within that we're defining what's going to multiply the product and add. So this is kind of, it should be secret adder multiplier, but I was in a rush. I only thought of this afternoon. And then we can see if we run this code, we'll get the number 5. Now, let's address the anonymous function in the room, which is that currying and lambdas lend themselves very well to each other. So we can see here we have the same kind of thing where we're doing lambda x, lambda y, and then lambda z, where these are just 3 anonymous functions nested within each other. This is going to return a function which will curry this statement, which is z times y divided by x. And then we can see here we're going to have to call lambda x, which is going to return lambda y, which is going to be 15 as its argument, and then lambda z, which is going to be 3 as its argument. So why is this practical? It isn't really. But I thought it made for a good title. But I suppose there are some use cases maybe with our diameter example. But then again, you probably just end up, putting 2 arguments in instead of currying it. But sometimes we like to dream, Anyways, thank you guys.